Hey, athletes. What we're going to talk about here is a follow up on conjectures. In this one, we're going to talk about the validity of our conjectures. So, what ends up happening here is sometimes you know, we start to make a plan, right? We're analyzing a pattern or a situation, and we make our conjecture. It's always good to take just a half a second to go and look back at maybe what we said what we wrote down for our conjecture and go, does that actually make any sense? So, especially with inductive reasoning. Okay, when we get to deductive, we'll analyze these in different ways. So, here we go. State whether the following statements are true or false. Okay, so it says points A, B, C all fall in a straight line. So, there would be the statement, and someone makes the conjecture they are all vertices of a triangle. Well, yeah, if I have 3 points, A, B, C, I could absolutely make a triangle, but not in this case because the statement is all 3 points fall in a straight line. Well, I can't make a triangle if all three of my points are in a straight line, can I? Okay, so this is where I'm going to go back. I'm going to say this is an invalid or false statement, right? A false conjecture. It doesn't make any sense. So again, this is what I'm talking about. We're just going to slow down and look at our conjectures and go, okay, did that make any sense? Like, am I happy with that? Okay, let's try another one. Side AB and side CD intersect at E. Then angle AEC and angle BED are equal. The other way to say that is congruent. Okay, so what's going on here? Okay, so let's think about this one just for a second. Well, let's draw a picture. If my pen wants to work, try that again. Let's draw a picture. There we go. There's AB. Let's label that as AB. Those should be solid dots because it's a line segment. Here's CD, so again, a line segment. And it says these two line segments intersect at some random point E. So what is this conjecture is telling us, or it's saying, is that angle AEC, that angle, is equal to angle BED. Well, yeah, that's a true statement. And the reason those true statements is when you're in this formation here, this shape, and you've got this nice axe, the angles across from each other are the same. They're congruent. And these two angles right here that I'm kind of drawing in that maroon color are the same. So this is a true statement. The reason is what those angles are called, my friends, which we're going to work with in a future unit, vertically opposite angles are the same, are equal. And another way to say equal in math, especially with proofs, is congruent. Okay, so that's a true statement. All right, so yeah, whoever made this conjecture, they were correct about that. Okay, let's try a couple more. Okay, if x plus 3 is equal to 11, then x is equal to 5. Okay, well, I mean, right off the bat, you can just try to verify this. You sub in 5, and 5 plus 3 is equal to 8, which is clearly not equal to 11. So this is a false statement. So sometimes what ends up happening, or false conjecture, is that we just make an error in our math. It happens, right? Okay, that was an easy one. Let's look at one more. So it says y squared is equal to 9, then y is equal to 3 or negative 3. Okay, well, where negative 3? I think most people would say, yeah, 3. Okay, here's why, friends. There's two ways I'm going to show this to you. What I'm going to show you, I think the easiest way to prove this is that I'm going to bring the negative 9 over. So I'm going to subtract both sides from negative 9. Now I've got a difference of squares, and I can factor them. And then using the zero product property, which we used when we were solving quadratic equations, is we set them both equal to 0 and solve. So this is absolutely a true statement. Now, another way some people attack this question is where some people would think this is false, is they say, okay, I got y squared is equal to 9. So I'm going to square root both sides because square rooting and squaring are inverses. And a lot of people, what we're used to over the years is saying y is equal to just 3. But that's not true. When we square root a function, we get a positive and a negative, and the reason we get that positive and the negative is from what we proved right here. These are called your primary and secondary roots if you want to be a huge nerd like me. Okay, so this would be a true conjecture. Okay, and then we just proved it right there. That would be the proof. So there it is, friends. It's just about when you make a conjecture, just analyzing your conjecture and saying to yourself, did I make something that makes a lot of sense or not? That's all. Okay, see you another time.